Hey everybody, welcome back. This is a new video. We are starting a new chapter on magnetism and electricity, and we're lumping them together, and I've said this a few times because magnets and electricity are two sides of the same coin. They're related to one another, and it has to do with how electric fields are produced and how magnetic fields are produced. And we're not going to get so much into that in this section. We're going to look at general properties, and today we're going to look at this thing called induction. And in order to talk about induction, we got to remember that the magnetic field is the magnetic field of a magnet is what attracts metals and other magnets. So remember, a magnet is anything that attracts a metal to itself. And so this is a simple bar magnet. Remember, magnets have two poles. We have a north pole and a south pole. And the magnetic field is this thing that exists between the north and the south poles. And what happens is we have this we get these loop shapes. So this attraction area loops from the north to the south, and they get into these bigger and bigger arcs around the outside of a magnet. So these blue lines represent the magnetic field. Okay, and this also happens on the underside. So North Pole goes just like this, and it loops back down to the South Pole. So if we're looking at the magnetic field outside of the magnet, it runs from north to south. It loops out of the North Pole and down to the South Pole. If we're inside the magnets, there's a magnetic field here. It runs from south to north in that direction. So pay attention to where you are. If you're inside the magnet, we're running from the South Pole to the North Pole. And if you're outside the magnet, it runs from the North Pole to the South Pole in that arcing direction. And this leads to something called induction. And induction, let's scroll down a little bit. So we're going to talk about these two things. Induction is a magnetic or electric field caused by something else. And this is a really, really broad definition. We're looking at general principles right now. So a magnetic or an electric field caused by something else. On the left-hand side, this thing is called an electromagnet. And on the right-hand side, this is an electric generator. And they run on the same principle, but they're a little bit different in their setup. So let's look at this one here on the left. The magnetic field, right? We can see a magnetic field here. If you had a coil of wire, so these loops of wire around an iron core, like a nail or a screw, if you just wrap some wire around it, it's just a wire wrapped around a nail. There's no magnetic field. We can cause a magnetic field around this thing by attaching electricity to it. So we take a battery, hook up some wires, and run it through this nail, or rather through the wire wrapped around the nail, and we induce an electric field. So an electromagnet has a magnetic field, right? So we get those attractive areas. Magnetic field induced or caused, induced by electricity. So when you have an electric current, and we're going to talk about this later, when you have an electric current, you automatically get a magnetic field as part of that. On the other hand, an electric generator, this one has a coil of wire, and this is doing the spinning around a magnetic field. So here in this magnet, there's a magnetic field between the North Pole and the South Pole, kind of like that. Take a coil of wire and you spin it, or you rotate it through that magnetic field, and you get electricity. So this one gives electricity. Induced by magnetic field. So depending on what you are running through, so here we're running electricity through an inert substance or a non-magnetic substance to get magnetism, and in this one we run an inert coil or a non-electrified, non-charged coil through a magnetic field to get electricity, and that's induction. So we have two things, electricity and magnetism, causing the opposite depending on what happens. Now we're going to build one of these in class. I've also put a link in the description of how you can build a simple electric motor at home that uses these principles. So there's a lot of things that you can do to play around with this very, very easily at home. So take a look at those links in the description and feel free to leave comments or questions below.